Hey everybody, so in this video we want to solve problem 694, number of distinct islands on LeetCode. So the problem is we are given a map and we have some islands and water on the map. As you can see here, so let me open my drawing tool. So as you can see on the map here, so the blue cells that has a value of 0 are waters, and then the cells with the value of 1 are lands. And a land, if there are two lands connected to each other, either horizontally or vertically, all of them together are considered as a single island. So here we are asked to return number of distinct islands. So what does that mean? So in the map here, as you can see, we have two islands. So this is the first one and this is the second one, but the shape of those islands are identical. So if I translate them here, so map them here with moving them, so the translation that referred in the problem is referred to just simply moving an island, either the whole island, either horizontally or vertically. So if I translate them, so they are both of them can be mapped to this single island here. So the total number of distinct islands in this map on top is 1. And this is the answer. So in order to clarify, so let's take a look at the second example that we have. So the first task is to find the islands. So we have 1, 2, 3, and 4. But the total number of distinct islands in this map is 3. So remember, translation only means that we can shift an island, the whole island, either horizontally or vertically, but we cannot rotate them. So this island on the bottom right cannot be translated to the island on the top left because we have to rotate that. But these two on top right and bottom left can be translated into a single island, because if I move them like this, both of them by moving horizontally or vertically can be translated into a single one. So in order to solve this problem, we have two steps. The first step, so step number 1, is to find the islands, which for that we are going to use BFS, so that whenever we find an isle or a cell that has a value of 1, we start labeling the neighbors until we reach the boundaries or reach water, and then we assign all of those cells into a single island. The second step is to define a way such that we distinguish them. So before doing the second step, let's simply just focus on the first step. So the problem, the first step to solve this problem, is to find the islands themselves. So in order to start, let's say first of all store the dimensions of the map somewhere. So it says we are given an m by n binary matrix, so let's use the same terminologies. M by n equals length of grid and the length of grid 0, and then we are just starting for I in range m, and then for j in range n. So whenever we find in an isle, so if the grid of I and j equals 1, and it shouldn't be visited. So if we have already visited from another sources, so for example, in the first one we actually see this cell, and then when we are calling our BFS on this cell, so from that we are eventually visiting the all neighbor nodes, and so these nodes should be removed from the further iterations for the islands. So and not visited. So again, for a visited, we can define a similar map, a binary matrix, so that we just flag a cell that we are visiting. But the problem is, for most of the 0 nodes, we don't have to store visiting value because we are not going to visit them at all. So in order to save some memory and at the same time have quickly access the visiting status, I want to use a hash map. In Python, I want to use the default dictionary. So from collections, import default dict, and define my visited default dict, and then the type is boolean. So by default, if we haven't visited and the key is not stored in this hash map, so by default it is returning false. Otherwise, we can set the value to true or false. So it depends. So here and not visited, and then the key is ing. So here we are starting the BFS to find the islands. Okay, so now our starting point is ij, and this, as always, in order to implement the BFS, we have to implement the queue, and then our starting node is ing, and then the visited of ing is true, and then while the length of the queue is greater than 0, that means there is a cell with a value of 1 that we want to visit, and then ing equals queue.pop 0, and then we need to check the 4 different directions for di and dj in 0, 1. This is a 4-directional map. So if 2 cells are connected to each other from the side, so if we have a 1 here, let's say, so these 2 islands are not connected. So only this is a 4-directional, horizontal or vertical connection. So we have 4 directions, -1, 1, 0, and -1, 0. So these are the 4 different directions. For simplicity, I can shift and move up here, the directions. So let's say if the problem changes into an 8-directional problem, so we simply just add the new 4 directions here, like 1, 1, and so on. So, and nothing else in the problem would change. So in directions, in order to compute the adjacent indices, so we have ai and aj equal I plus the direction in I direction and j plus the direction in j direction. First of all, we need to check if that cell is already valid, so that means it is not beyond the boundaries of the matrix. So it should be greater than or equal 0, ai less than n, and 0 greater than or equal to aj less than n, and the cell itself is an island, so ai aj equal 1, and not visited again. So we want to use the same, and not visited ai and aj. First of all, we change the visited to visited of ai aj to true, so that that means we are adding that to the queue, and then queue.append ai aj. Okay, and somewhere we need to store the cells of this island itself. So the island, initially it's an empty list, or initially we can consider, so whenever we are visiting a cell, we are adding that cell into our island. Island to append the I and j. So after, when the BFS here, so we are running BFS here, and when it is over, we already found all connected cells of the island here in this list. So this would be a list of the island equal list of island cells in ij format. Okay. Oh, and so the visited is true, and okay, so that's it, that should be fine. And here we have our island itself. So for now, so this is the first task. So for if you want to complete it, we can say islands or total islands equal an empty list first, and then when we finish running here, total islands that append the new island that we found. So what do we have here? So now in this line we have a list that already we have the list of islands that we have in the map. The second step is to map is to see how many distinct islands that we have in the total island list. So in order to solve this problem, this is the second step, we need to find a way to see if we can map two islands into a single translation. Since by the definition of translation in this problem is we can either move the island horizontally or vertically. So the way I want to use one way, so we need to find an identical map or a hashable string somehow that we can map. So given some islands, so let's say given a set of islands, we need to find the hash function so that all of them are mapped into a single position. So for example, this is unique, and since these two islands are identical, these two should refer into a single value, and this should refer to a single value itself as well. So what I want to use is that given two islands, consider we have some here with different values, or let's take a look at the real example. So here, these two, for example. So these two has different indices. The one on the left, on the bottom left, has the indices are, this one is 4, starting from 0 is 3 and 0, and 3 and 1. And this one has a value of 0 and 3, 0, 1, 2, 3, and 0, 4. What happens if we map, regardless of where the island exists, we map all of them into a 0 and 0. So here is the 0, 0 in the map. So in I and J are in this direction of how we are storing arrays in Python. So here, what happens if we find the minimum values in X and Y directions, or in I and J directions? We first find the minimum values for each of them, for each island, and then subtract those minimum elements from all cells in them, so that everything is now mapped into XY0, XY. So here, this is our XY, for example. So let's say this is our X. So in the real world, this is X and Y, but in the way that we define the matrices, so it doesn't matter what is X and what is Y. But if we map everything, so we have one, the first one is here. Let me use other colors. So the second one should be mapped to here from the left, and then the other one will be mapped into a same position, and so on. So my idea is to map everything to 0 and 0, and then sort the indices in that list into a tuple or a string. It doesn't matter, so something hashable. So the strings, tuples, integers are hashable. And if we sort them, so regardless of what are the order of the indices that we have, so let's say given this island in this shape here, if we start from, we have found the indices in the list in this order, or in the from right to left, if we map them first to 0 and 0 and then sort them, we make sure that the array for both of them are identical, so that we can say that these are not two distinct, these are not different, and so those two islands are identical. So let's jump into the implementation and see what we have in mind. So let's define a function. This is our hash function. The input is an island. So first of all, we need to find the minimum xy values. Find minimum xy values. So the mean I, or the first one, the first index in ij format. The mean I is the minimum of I for I and j in island. So island is a list of tuples. So I can define, okay, so the mean I, and then mean j is the minimum of j values, likewise I and j in island. And then we want to define, so we first subtract all values from mean I and mean j in island and sort them. So the sorted array would be the sorted of I minus mean I and j minus mean j for I and j in island. And then, but the arrays themselves are not hashable. We should either convert this array into a string, so we can say, let's say with comma separated, or simply just put them and let the join and convert everything to a string, or we can convert the whole array, the whole list. This is a list at this line. Convert it into a tuple. So return the tuple of this sorted array. So this is our hash function. And using this, we are making sure that the total, if two islands are identical, we are mapping them into a single value. And then we can use a set. So the total islands is now the arrays. So first of all, we are return, if I use, let's say, a set of calling this hash function an island for island in total islands. So the set itself is making sure if there are two identical values. So for example, the sets, if we add 2 in this set, it doesn't add that because this value is already in there. So by converting this to a set, I'm making sure that we are just storing identical values. And then the problem is asked to return the length of that, the total numbers. So this is our set, but we can simply just return the length of this set. So this is the second step by using this return and using this hash function. So let's test that. Okay, it should be fine. So let's the second one. Okay, that's fine. And don't forget to always test the edge cases. So here it says the m and n values are between 1 and 50. So let's try it for 1. And let's say 0. Let's say 0 is not a value of the type integer. Oh, I forgot a bracket. And then test it with 1. We should expect to get 1. There we go. So let's submit that. All right, perfect. So yeah, that was everything for this problem, problem 694. If you like it, you just like the video and look forward for other solutions.